Welcome to Monday, half hour or no, 1 hour delay. So it's Monday morning, and we're working through just a warm up of one questions from all three sections of Chapter 7. The first two questions we have here are monomials divided by monomial and monomial times monomial. The second question gives us a question from 7.3 on dividing a polynomial by a monomial, also multiplying a polynomial by a monomial, which is a 7.2 concept. And then our last two questions are modeling both the multiplication of a monomial by a polynomial and dividing a polynomial by a monomial. So we'll start with the first one. 7.1 asks us to do this, and since it does not give us an expectation of how to do it, remember what we want to do. We want to think of it as being this particular question right here. This is what our brains are thinking. We don't have to write that, but that's what we need to think. And when we actually do our work, we're asking ourselves, a 2 divided by a -2 is going to be a -1. Keeping in mind, we've always said keep your negative sign in the coefficient. I'm going to put a -1 there. And x4 divided by x, or x to the fourth divided by x to the 1. Remembering that dividing like bases, keep the base and subtract your exponents. Oh, that's not an x. That's a 4. That's the wrong one. That will equal x to the power of 3, which means when I reduce that down, it's going to give me x to the 3. When I multiply my numerators, I'm going to get -1x cubed, which will just be -x cubed, because a -1 coefficient is just negative, over 1, which means my final answer will simply be -x cubed. When I look at my next one, we're going to use the associative property of mathematics to remember that that's 4 times x multiplied by -3 times x times y, which when I rearrange the terms, because it does not affect its product according to the associative property, I'm going to get -12 x squared multiplied by y. And my final solution would be the monomial -12 x squared y. In question 7.2 and 7.3, we have two different questions. This is your 7.2 question. This is your 7.3 question. In both cases, we're going to use distributive property. I'm going to start with the multiplication here. So really, that's just two multiplications of a monomial by a monomial, because each term in the polynomial must be multiplied by the monomial inside the brackets. So when I write those arrows, I'm going to remind myself that it's going to be 4x squared multiplied by 2x, and it's going to be 4x squared multiplied by -3. Those are the two 7.1 questions I'm going to do to bring them together. Rearrange them using the associative in your head. You're going to end up with 8x cubed. Rearrange them in your head. You're going to end up with -12x squared. When you bring those together, your solution will be 8x cubed minus 12x squared. When we do 7.3, we're going to do the same thing, except this time instead of multiplication of a monomial by a polynomial, we're going to divide each part of the polynomial by the monomial -2x. So we're going to think of it as this. We're going to think of it as this term here, and we're going to think of it as this term here. Once we have that, we're going to do it just like we did in the first part, divide the coefficients to get a positive 6 over 1. Divide the variable terms, it's going to be x to the exponent of 1, or just x over 1, which means my solution will be 6x for that one. Over here, remember it's a negative divided by a positive. Keep your negative sign in your numerator, -3 over 1. X over x cancels each other out. I'm left with just -3. And I end up with 6x minus 3. Now, if this was a test, you could reverse it and say this multiplied by my answer should give me this. And if I use distributive property here, I will see that indeed it does give me that answer. So my answer is correct. Question 3 asks us to model this. So we could think of this as being length times width equals the area, this being the area inside here. So I'm going to draw my length as -3x, -1x, -2x, -3x. And my width is going to be a positive 2x, which I'm going to shade in to be positives, and a -1. My area inside, if I just brought it down to its basic part, would be that. If I make the line connections to everything, I end up with that. These are going to be negative x squareds because a positive times a negative is a negative. So we end up with negative 6x squareds right here. And since this is a negative and this is negative, these are actually going to become positives because a negative times a negative is a positive, meaning the area is negative 6x squared plus 3x. So therefore, the solution is negative 6x squared plus 3x. And our final question gives us a modeling of division. This being the area, this being the side length, and this one being the side length that we don't know. So when we model it, we always start with what, Hayden? If I'm going to model this, do I start with my area or my side length? Always start with your side length. So I'm going to put just an 8 or an x here. That's my x. That's my side length that I know. Now, in order to fit this area in here, I'm going to put a line right across here. It's actually going to be quite a big one. And I'm going to put 1x squared, 2x squared, 3x squared, 4x squared. I'm going to run out of room. So I'm going to bring it over here. 1, 2, 3, 4, 5, 6, 7, 8. These are all x squareds. 8 of them to be exact. Oh, that's positive, sorry. And then I have to fit an additional negative 2x. I'm just going to put negative 2x there. And now I have my side length and my area. And my missing side length. Oh, that's not long enough. There we go. And there. There's 8 of them. They're going to be positives because a positive times a positive. And these two here are going to be negative. So negative 1 and negative 2. So therefore, my solution will be 1, 2, 3, 4, 5, 6, 7, 8 x's and negative 2. So the solution from a modeling standpoint is 8x minus 2.